Hello everyone, welcome. Today we are going to look at the another fundamental and beautiful aspect of physics. We are going to explore projectile motion. We started motion, the simple straight line motion we have seen before, and then we are going to take a leap into the second dimension to understand how things fly. So let's get ready to build a deep understanding of motion from straight lines to a parabolic flights. We have seen VT graph before. In that, we have seen that the area under which area covered by the this graph shows a displacement. So today we are going to see that how we find the area. So in this graph, we have this straight line, okay, and this is kind of area covered by the this curve. So for that, we took into two parts. First one is the triangle part and second is rectangular part. For that triangular part, we know the area of the triangle is 1 by 2 into base into height. So we have 1 half into base. Base means this. This is the 16 and the height is 30 minus 10 means 20. And we'll get the answer about 160 meter, which is the area of a triangle. Now, for rectangular area, we know the area of a rectangular means length into breadth. Means what? Length. Length means 0 to 16 means 16 into breadth means 0 to 10 means 10, and which also gives 160. And you have to just add these two means 160 plus 160 means 320 meter. So that means you can say the displacement of this object is about 320 meter. So now the unit of displacement is a meter. Now this is all about how we find that the displacement from the velocity versus time graph. We will see, but what happens when the line on your VT graph, or you can say velocity time graph, is not a straight line? What if acceleration is changing and the graph curves like this? Simply geometry like triangles and rectangulars don't here work, okay? So this is a common problem, but don't worry, we have a solution using the counting square on maps. So how we find? First, you have to find the area or of this one box. So to find the area of this box, so you have to just find the area means length into breadth. What is the length over here means here is scale of time here means 2. So write 2 here, and in the velocity axis you have a the coordinate here is 5. So it is 5 over here, and which give you a 10. Now 2 is in a second and the 5 is in the meter per second. So that means it will give you a 10 meter. Okay, this is the for the one box only, not the entire area. So in order to find the displacement of this object, or you can say this any object, so you have to just do the value of the one box multiply by with how many box are under this curve. So if there is a 100 boxes, fully boxes covered by this area, which will give you a 1000 meter like this. So if the graph is like like this, don't worry. You have to just calculate the one area and the multiply by with the all other boxes. Okay. So this is about for the non-uniform acceleration, how we find the displacement over here. Now, for situations where A is the constant, we have a something even more powerful than graphs, which is formulas. But the challenge is how do you know which one of the use for the particular problem? So don't guess here. I here draw entire table for you. So in the question, you have to identify the which variable is given and what they ask for. Means let's try to figure it out. In the first equation, we have a final velocity, initial velocity, acceleration, and the time. So you have a basic variables is displacement, initial velocity, final velocity, acceleration, and the time. So in this equation, you don't have a displacement, or you can say distance. You have a u, v, a, and t. So if in the questions they ask for a displacement, and you have a all these things, or you can say this quantity which are given to you in the question, so you have to use this kind of this first equation. Now in the second equation, you you have a SUTA, so you don't have a V. So if question is like this, they ask for a V and they give these quantities. Use this equation and like this way. And the concept is don't guess. Identify the variable the question doesn't give you and doesn't ask for. Pick the tool with the X for the that variable. So first time you read a question, you have to identify which variable are given and which for they ask for. So first you identify this and you will able to solve any kind of problem regarding this. We are entering to understand the projectile motion. Now, Galileo saw that the projectile is not a complex motion. It is a two simple one-dimensional motions happening at the exact time. So Galileo saw that there is a one motion here and one motion here. There are two 1D motion simultaneously. Okay, this is the kind of basic structure of projectile motion. So let's what is going in the projectile motion. Let's suppose the coordinate system which is here is a velocity and this is about time. Now, if you have trajectory like this, give you two components of Vx and Vy, means horizontal velocity and the vertical one. Now, to understand the projectile motion, we have to first understand the velocity Vx component and Vy component, means vertical component separately. Okay, so how we do? Let's find out. We are entering now. I show you here the two tables. One is for horizontal motion and the another is vertical motion. So on the horizontal side, which is in x direction. Once an object is launched, there is a no force acting on it horizontally if we ignore air resistance. Okay, so that means we don't have a force in this direction. That means we don't have acceleration over here because force is a cause of acceleration. That means ax is 0, not ay. We don't know. We will see. Okay, so we know the ax is 0 because there is a no force in the horizontal direction. Now that means we know if there is a no acceleration means velocity is constant throughout the motion. Okay, yeah, right. Ux is constant means initial velocity through the entire flight is a constant. Okay, so the equation is like this: ux is equal to ux into t. T is a time over here. X is a kind of displacement or distance, and ux is the initial velocity of in x direction, or you can say horizontal direction. Now, in the vertical motion, the case is different. Okay, so we know the gravity is constantly pulling the object down, means the object is going like this. We know the gravity is always there. Okay, g is pulling downward this object. So that means we have a force here due to g, gravity. Okay, that means in the vertical motion, there is a no velocity is a constant. Means Vy is not a constant over here. Okay, so there must be some kind of acceleration which is g, and here I write Uy changes continuously under the uniform acceleration. So for that, we already saw five equations we use when the a is a constant over here. So here a means g is a constant near the surface of the earth. So here we use this kind of equation, and the basic difference over here is horizontal motion is doesn't affect because there is no force in the horizontal direction, but in the vertical motion there is a force called gravity constantly acting on it. Okay, but the time, the the only one variable shade between these two dimensions. The time links the horizontal and the vertical words. That means the time it takes for the projectile to raise and fall is the same time it uses to travel horizontally as well. This is a critical link. I hope you understand these two motions, the horizontal one and the vertical one, and what is the difference between these two. Now let's understand what is going on when the object is going. So let's see in the action. Imagine the projectile is launched over here. It makes some angle theta over here with the horizontal. Now it goes the maximum height, and this arrow shows the velocity direction. Okay, this is the resultant velocity. Means here we have a Vy component and we have a Vx component. Now, if move towards like this, the the trajectory of this object is like some kind of parabola. Here you can see like this. Now, if you want to find found that what is the velocity over here, so it must be contain the Vx and Vy component. As we know, the velocity is a vector quantity. We don't add just like a scalars like Vx plus Vy. It is wrong because this is a vector quantity. For that, we should do the vector sum. So this is the Vx component and the Vy component over here, and the resultant velocity about like this direction. So we know the formula of the resultant one is like this: v square is equals to vx square plus vy square plus 2vx vy cos theta. So what is theta here? Theta is the angle between these two components. Here, in this case, we have a theta is equals to 90 degree. So put this value over here and you will get the cos theta. Cos theta means cos 90 degree means 0. So this term will vanish and you will left with vx square plus vy square. And when you do find the value of v, you will get vx square plus vy square. That I will show you here. So if you find the resultant component, you will need only vx component and vy component. Okay. I hope you understand this kind of the trajectory of this projectile. Okay. Now the question you want to ask, like, why is the projectile motion always the perfect parabola? So it's because of the beautiful symmetry in the physics. So gravity is constant force that acts equally on every part of a projectile because gravity only acts vertically, not horizontally. Okay, as I we understand earlier that there is a no force along in the horizontal direction, only in a vertical direction. Meanwhile, the vertical motion is uniformly accelerated, means g is acting always on it, and the value of g is constant throughout the motion. When you take a constant horizontal motion and combine it with uniformly accelerated vertical motion, means there is a Vx is the constant velocity motion and Vy which is a constant accelerated motion. When you combine it with together, the mathematical result is like the physical path is always perfect parabola. The nature follows the mathematics with incredible precision. As you saw in this picture, the water come out through the pipe is like this, like parabola. Means it is kind of projectile motion. Okay, so this is all about the nature and beautifully we can describe the nature by the physics. One of the most practical questions in projectile motion is how far will it go? If you throw some kind of object, so how the object is covered the distance, okay? And at what angle we can throw the object so it cover far distance. So for that, so let's think about the what factors affect the range. Okay, first we need to consider the what factors we need to consider for we if we get the maximum range. So it depends on the launch speed, means the velocity. Okay, and another means one is the launching angle, means theta. So let's suppose here we'll take theta and here I show the 30 degree, 40 degree, and the 60 degree. If we take v as a constant, okay, let's suppose v is equal to 100 kilometer per hour. Okay, just suppose. Now we if we constant v and we make some angle theta like 30, then 45, and last 60 degree, we say we saw that the at the 45-degree angle we got the maximum range of the object. Okay, so that means here I write the range formula, which is u square sine 2 theta upon g. Here you see u is a fix, we can fix amount, g is always a constant, and we have to consider about sine 2 theta, means when the sine maximum when angle theta 90. So from that we can also get the theta degree from the formula. Okay, so this is a crucial concept for anyone trying to throw, kick, or launch something as far as possible. Okay, you have to just fix the magnitude of velocity and try to launch at the 45 degree and you will get the maximum range of it. Now the rules of kinematics are not limited to gravity. The same beautiful parabolic motion happen in another area of physics, like in electronics or electrostatics. This ray, let's suppose this is a kind of electric field, uniform electric field, I can say. The electron is going like this, perpendicular to the electric field. Now the velocity over here is v. Now it pulls like this way. So that means the electron velocity in the horizontal direction is constant, but the velocity of the vertical one is kind of affected by this electric field. So here, in that case, also you can get the projectile motion. Okay. Now let's take a step back and summarize the key vocabulary and concept we have learned so far. So summary notes one here. For that, the nature of quantities means we already know the scalar means magnitude only. There is a no bother about the direction. Okay, so in that we have distance and speed. In vectors, we have to consider the direction as well. So in that we have displacement and the velocity. Now the measuring rates. Okay, so we already saw the some average velocity, average acceleration. For the instantaneous, we need the velocity at the particular time, like at 2 seconds. We need instantaneous velocity, not the average one. Okay, so at the specific, the exact moment, how you can measure from the graph. Okay, to wrap up our graphical analysis, here are three golden rules to remember. First one is the slope of a displacement versus time graph gives you velocity. Another one is a slope of velocity versus time graph gives you the acceleration. And the third one, the area under this curve gives the velocity versus time graph gives displacement. This is the fundamental connection between the graphs and the physical quantities it represents. Keep them in mind and you will able to interpret any motion graph. Finally, let's summarize our main mathematical tools for a motion. First, remember this five equation and when you solve a problem, you have to identify which variable is given, which is not, and which is asked for. Okay, according to that, select the equations. Now, the free fall rule means object falling freely near the earth. If you ignore the air resistance experience, the acceleration of it is about 9.81 meter per second square. Now, the last one is golden law of projectile motion. So, if you understand the projectile motion, study as a two independent motion in the one direction. Okay, the one dimension. So, first consider the horizontal velocity, and then you understand the vertical velocity and considering with the acceleration. Once you master these rules, you can solve any projectile problem. Now, this is all about theory of your kinematic unit. From my next video, we will solve problem and exercises regarding we have learned so far. Thank you for watching. Subscribe for more physics lectures. Finally,